The next presenter will be Joseph Cleghorn. He's actually from the Institute for Landscape Architecture, and he's going to talk about applying algorithmic tools to landscape design. The floor is yours.
Okay. Good evening. We heard a lot of interesting talks in the first session about the use of algorithms to analyze and to simulate. The focus of my doctoral research is on can algorithmic models be used as a design tool to test new strategies and to improve living conditions and reduce risk in informal settlements. To answer this question, part of my doctoral research develops a case study. Is this it? Yeah. Develops a case study carried out by a team from the Leibniz University Hanover and Urbam IFIT in Medellin, Colombia. The research published in the report Rehabilitar la Ladera looked at the dynamic processes shaping two communities at high landslide risk on the steep slopes surrounding Medellin. The team proposed a series of pilot projects consisting of sets of interacting strategies whereby local community members could reduce landslide risk through a combination of anticipatory and mitigatory measures. My follow-up research to this initial research sought to test the spatial implications of the initial research's strategies through algorithmic modeling of many of these strategies. Many algorithms were used in the creation of the spatial design for the pilot projects. Here I give a brief example of one of them used to subdivide parcels for urban agriculture on steep slopes, a system much better adapted to this condition than a conventional grid. Parcels are divided using a recursive loop that alternates between divisions along contour lines and divisions perpendicular to them. A parcel can exit the recursive loop upon meeting one of several exit conditions, such as if its average slope is low enough. If the slope remains high after many subdivisions, an algorithm goes through a second series of operations to draw slope stabilization measures, also based on a set of rules. Similar algorithms were used on the other pilot projects to test the spatial implications of the strategies explored in this initial research. These range from the procedural creation of buildings, which paralleled the existing fabric, an algorithm to determine an optimized network for placing slope drainage machines, or an algorithm to delineate parcels for new housing in areas of low risk, taking into account slope steepness, but also considerations of access. In the end, an algorithmic approach does not eliminate the need for careful design thinking and methodology. In fact, the need to carefully consider each step in the process in a logical manner forces the designer to think carefully about the logic of the strategies as they would be deployed in the real world and how they might be implemented by members of the community. Developing a straightforward, replicable system for strategic interventions, however, can be of great benefit in any context, but especially in low-income communities where continual supervision from designers is not economically viable. The algorithm can define the DNA of a strategic process, which can later be adapted by the community to diverse specific conditions. Here, cutting-edge computational design approaches the logic of vernacular design with its ingrained rules and procedures and removes itself from the glossy and gratuitous form-making often associated with computational approaches. Thank you.
Okay.